All right, let's learn about MapReduce. In Earth Engine, when you are doing any processing, to leverage all the computation power that Earth Engine has to offer, you need to write your programs in a certain style. And learning how to do that will help you write code more efficiently and make your processing go faster. So let's learn about what is this different programming style that you need to learn to program in Earth Engine. All of you are here and want to learn Earth Engine because of the massive computation that it offers you to apply your Earth observation data analysis. But to do this, Earth Engine requires that you describe your computation in a certain way. A brief review of the Earth Engine architecture. The request, this is where you can imagine you are. So if you're writing code in code editor, you are sending a request to the Earth Engine system. If you are in a Colab notebook or in RStudio writing Earth Engine code, you are also here and you are sending the request. When you write your Earth Engine code and say run, whatever code you've written, either in R, Python, JavaScript, that gets turned into a request that the Earth Engine system can understand. And it gets sent to this system. So the blue box here is the Earth Engine system. You can imagine a data center with lots of machines, and it's listening for this Earth Engine request. And those requests come in, and the system understands how to interpret the request, and it can do things. Remember that this Earth Engine system does not understand JavaScript. It does not understand Python. It does not understand any other language. It understands the API. Right? So as soon as you click the run button, your code gets turned into this Earth Engine request, and that gets processed. And that's why when we want to do any work using the Earth Engine system, you have to use the API because the system understands only that. The system here has a bunch of machines, hundreds of thousands of machines that are running the Earth Engine software. The software knows how to do all the basic tasks with images and features and all of that. It also has access to the data. This is also the core of Earth Engine, that the data is co-located in the same data center as the computation machines. That means when it says, I want to fetch this image, it doesn't have to go out on the internet and download it. The data is right there. And that enables Earth Engine to do this data processing very, very fast. So you request Earth Engine for, let's say, I want to see this annual median composite of this region. It comes here, it distributes that work to all the different machines. Each request gets split into different tiles, and each machine gets to process a very small amount of that computation. So each machine says, I'll only compute a small tile. It fetches the data it's needed for that, processes that, and other machines are also doing the same processing for different tiles. And once all the tiles computation is done, the system combines all of that and sends you the result. To create a composite, it may have used terabytes of data, but all you get is the answer. Like, you don't get any intermediate data set. It's a very low bandwidth system. If you send a request and say, give me the total area of water in this reservoir, to compute that, you may have to do a lot of computation and download a lot of data, but at the end, you'll just get a number back. Right? So all the kind of data transfer is localized within the Earth Engine system. Now, to allow the system to efficiently distribute this work over different machines, you need to describe your computation in a way that allows for that. So that's the key of programming in Earth Engine. Here is how you do the processing. And typically in Earth Engine, you start with a collection. It could be a feature collection, it could be an image collection. And the first step would be to filter out the data, to get the data that you need. So you can filter out data from time range for images that fall in your region or certain metadata. You apply a filter, select the images that you want, and then you say, what is my computation? So you describe your computation, but not for every image. You just say, given an image, this is what I want to do. Given a feature, this is what I want to do. And you just need to figure out how to process one image or one feature or one time step. Once you do that, you can say, go and run this computation across all my images in a collection in parallel. So in Earth Engine, if you want to do something for all images, you don't write a for loop. Instead, you can say, here's a function that tells me how to get one image and process that, and I can map that function. This is a small map, M with a small m, map with a small m. It's not a capital M, but it's a map. This is a computer science terminology that says run a function on each image in parallel. So you map a function that does something with each image, and you say, now I have all images processed. What do you want to do with it? So the next step in the processing would be, once I have done the processing, what I want to see there as a result. You may say, I want to see a composite. So give me a composite and give me an image. That's a reduce operation. You can also say, I want to see a table. I want to see some statistics of each polygon over this image. And that's a statistical operation. That's called also reduce. You can ask for a chart, and that's also a reduce operation. So in Earth Engine, your workflow is typically, you apply some filters, you map the function to process that collection, and then you reduce the results to see the result that you want. And so now what you want to do is you say, I want to get the surface water area statistic for this polygon. You need to think about what filter would I use, what function would I map, and how would I reduce my results. Once you break down a problem into this component, programming in Earth Engine will be simpler, and you'll be able to translate your workflows into what Earth Engine needs. So how to write code that can be efficiently parallelized across machines? Well, filter a collection, write a function to process a single image or feature, map that function in a collection, and reduce the result. Right? Again, this is very abstract. Once you see all the problems being solved in this way, you'll understand more how to really apply this in context. But whenever you're working with Earth Engine, remember, no if statements, no for loops. Your code has to follow this template of filter, map, and reduce.